Hello everyone. Welcome back to the lecture series of 71-day course for the preparation of CEED exam. As you must already aware of that in this series of 71-day course, we are going to be covering the entire syllabus of your CEED exam, that is including part A and part B. For part A, based on the syllabus and the previous year's questions, we have divided the entire part A into sections, that is analytical aptitude, visual and spatial reasoning, logical reasoning and design knowledge and creativity. All this is going to be part of your computer based test, and apart from that you will have foundation and basic concepts, core skill development, application techniques and all. This is a part of part B, wherein you will be tested based on your sketching and design skills. So for today's lecture, we will be focusing on visual and spatial reasoning, which starts from day 6 to it continues till day 14. In today's lecture, we will be focusing more on day 12's topic, that is tessellation. Now for any of the topic that we talk about under part A, practice is the key. You have to practice as much as possible to solve these questions quickly and correctly in your exam. For that, we have uploaded a lot of question papers online, which is available free of cost. What you have to do is you have to download our app from the Play Store, which is also available free of cost. There you will have access to the question papers and the test series. So more on that later. Let's talk about our today's focus, that is tessellation. Now under this particular topic, based on the previous year's questions, we have subdivided this topic into two, that is one tessellation and two is tangram. Now what are these? So tessellation is basically repetition of a shape or an object. Okay, it can be rotated also, but the key is that it needs to fit exactly into the previous shape without leaving any gaps. Okay, it can be fitted one behind the other, or it can be rotated in 90 degree or 180 degree so as to it fits. For example, in this case, it is getting rotated, this arrow, one shape looks like this, and then it is rotated 180 degree to fit into it, and the other shape looks like this. Okay, this is also one of the examples of tessellation. Others can be where you are tessellating more than one object. For example, you are tessellating a pair of square and triangle. Okay, even that will come under your tessellation part. Now what is tangram? Basically, one square is divided into 7 parts. Okay, and with the help of these parts, you can make n number of objects. Now, as you must have already observed, the difference between these two are, here we are keeping the object or the shape same and we are repeating it infinite number of times. And in tangram, what we are doing is, out of one shape, that is of square, we are picking out pieces and then we are rearranging it to form various other shapes. Okay, so the kind of questions that we get in CEED exam are with respect to tessellations. You can get a rotation of 90 degree as well as a rotation of 180 degree in the question or of the shape, and you can also have scaling of that particular shape or flipping of that particular shape. For tangram also, the questions can be based on either scaling of one of the parts of that particular shape, it can be based on rotation of it, or it can be based on flipping of it, and you can be asked to identify which one is the correct tessellation or which shape can tessellate, or under tangram you can be asked, for example, which of these shapes can be obtained from that particular part of a square. Let's understand what tessellation is. So tessellation is a shape. Okay, so let's start with tessellation and understand what it is. Let's go into the detail of it and let's try and solve a few questions based on that. Okay, so starting with the definition of tessellation. A shape is said to be tessellated if an infinite number of that shape can be put together with no gaps or no overlaps. For example, if I am tessellating a square, repeating it a number of times. Okay, so let me choose this particular vertex and let me draw another square. Then again, let me choose this particular vertex and let me draw another square based on this. Like this, I can go on infinite number of times and I can repeat this particular square without leaving any gaps or without having any overlaps. So till now, we are sure that square can tessellate. Let's try and increase this widthwise and see what happens. Okay. I can draw a square just below it and then keep on tessellating it like we did for the first row, or I can even draw a square in this manner, that is right from the center of the previous square, and then also I can continue tessellation of this particular row. Now by this example, we now know for sure that a square can definitely tessellate. And based on this example, you can also say that a rectangle is also going to tessellate always. Now let us talk about a triangle and see what happens in that case. For example, let's say we take a triangle. Okay, can this shape tessellate? Let's check. Let's keep on drawing triangles vertex to vertex and let's see what happens. Okay, here you may say that triangle is leaving gaps. Now let's check. If we invert this triangle or rotate this triangle 180 degree and then if we try to fit it in this particular pattern, what happens? We are able to see that it is perfectly fitting into one another without leaving any gap or without overlapping. For example, this is one triangle and this is triangle number 2. This is triangle number 3. This is triangle number 4 and so on. Okay, so we can see here this triangle can tessellate. Now let us check with another example. Let's take a different triangle, for example, and let's check whether it tessellates or not. Okay, if I keep on drawing these triangles and then if I add inverted triangles to this, again we will see that it is coming up with a seamless pattern, or we can say it is adding up to a very seamless pattern. Okay, so this is triangle 1, 2, 3, 4, 5 and so on. This can continue for infinity. Okay, what about above and what about adding triangles below this particular pattern? Again, we can add one inverted triangle here and one straight triangle here, inverted here and straight here. Likewise, we can continue it lengthwise and we can also continue it widthwise. As a matter of fact, you can say that any triangle, be it a scalene triangle, be it a right angle triangle, isosceles triangle or equilateral triangle, if we are talking about any triangle, it is going to tessellate. Now let us look into the reason. Why can we be so sure about this? For example, let us consider this particular pattern. Okay, what is happening here? We are tessellating a triangle, okay, and at this vertex what is happening? Let's take another example. These are also similar triangles tessellating and forming a square. Now let's check what is happening at this particular vertex. Okay, we can see that angle number A, angle number B, angle number C and angle number D will add on to be equal to 360 degrees. Okay? Similarly, these are not similar shapes that we have tessellated but different triangles. Even in this case, if we add all these angles, it is going to be equal to 360 degree and hence we can be so sure that it is going to tessellate. Now let's look at another shape. Let's take any quadrilateral for example. Okay, let's start with a very basic one. Let's take square. Can the square tessellate? Yes, we can draw n number of squares in this line. That is going to test it. Let's check whether we can increase it width-wise. Yes, we can. Similarly, we can try and do this with a rectangle as well, and we will know that these rectangles also tessellate. That is how you get the brickwork pattern. That is how you get any tile pattern. Okay. Now let's check for a very random quadrilateral, for example. Something like this. Is this going to tessellate? Let's check. Okay, now you may say that all these are very basic shapes, or this can be a fluke as well. But you must know any quadrilateral that we are talking about, if we add its internal angles, it is always going to add up to 360 degrees. So that is how we can say that it is going to tessellate. No matter what the next angle here comes as, it is going to add up to 360 degrees. Okay, so triangles, quadrilaterals and hexagons will always tessellate. Okay, now how to check tessellation for random, or you can say shapes which do not have sharp edges. Okay, for example, let's take this fish. Now what is happening here is, let's try and make a square around it and see what is happening. For example, this is the square that I am making around it. Now whatever I am cutting from here, I am adding here. Exactly the shape that I am cutting from here, I am adding over here. So what is happening is, because these two shapes are exactly the same, when I start tessellating it, it is going to fix into one another absolutely without leaving any gaps. Okay, let's check for this. Let's try and make a square around it. Okay, what is happening is, if I am deducting a curve from here, I am adding the curve at the top. If I am deducting a W from the left, I am adding a W at the right part. So as a thumb rule, you should remember, if we make a square around any such random shape, if we are deducting something from the bottom, we should add it to the top, and if we are deducting something from the top, we should add it to the bottom. Similarly, if we are deducting anything from left, we have to add it to the right, and same holds true for vice versa as well. Now let us check what kind of questions are usually asked in CEED. Let us try to solve one with the same logic and see whether it works or not. Tile X used to create a pattern which is seamless without gaps when arranged as shown in Y. Which tiles from these options will create a seamless pattern? Now first you have to observe what is given to you. This is the shape that has been given and it has been repeated multiple times. Okay. Note that this shape is not rotating anywhere, it is not flipping anywhere. So it is getting repeated as it is. So similarly, we have to check for the other shapes as well. Let's begin with shape A. What is happening here? First of all, we know that if we draw any square around it, whatever is getting deducted from one place should get added to another place. For example, we are deducting L from here, but we are not adding L here. Why? This is a slant and not a L-shaped structure. So hence we can say that A is not going to tessellate. Let's check for B. Let's try and draw a square around it. Okay, we are deducting a triangle from here. We are adding the triangle at the top. So for this one, it works. Let's check for the other one. We are adding a triangle here and deducting a triangle from here. So this also works. Now what will happen? Whenever we go ahead and repeat it infinite times, this particular shape is going to fix exactly with this shape, leaving no gaps. Okay, so this is going to tessellate. Let's check for C now. What is happening in this case? Okay, let's check for this. What is happening? We are adding. Okay, let's make a square around this and check if it works for this shape or not. Okay, let's see what is happening. First of all, we are deducting a triangle from here. Are we adding it anywhere? Yes, we are adding it over here. Now let's check for the other shape. We are deducting a semicircular type of shape from here. Are we adding it to the right side? Yes, we are. So this is giving us a pattern which is going to fix exactly with each other. Meaning this circle is going to fix into this circle and this triangle is going to fix in this shape. So this is also going to tessellate. Let's check for option number D. Again, let's draw a square around it. Okay, we are deducting a triangle from here and we are adding it here. Okay, it is true for 1. Now let's check what is happening at the left and the right side of this triangle. We are adding this triangle over here. We are also adding a triangle on the other side. Now this is not going to work. If we are adding one triangle on the left, we have to deduct a triangle from the right. Okay, had it been something like this. Okay, let me draw it, simplify it for you and draw it again. If this particular shape would have been something like this, then it would have 100% tessellated because it holds true for bottom and top, it holds true for right and left. But in this case, it is not going to tessellate. So the answer for us is option number A is not going to tessellate, B is going to tessellate, C is also going to tessellate, and D is not going to tessellate. So under this MSQ option, we have A and C as the answer. I hope you are able to understand the process of it. But let's practice more and understand it. Okay, again, a tile has been given to you and it is tessellating. Let's observe what is happening here. The exact tile is repeating infinite times. There is no flipping and there is no rotation. Okay, so similarly we have to check for A, B, C and D. Let's check what is happening with A. Let's draw a square around it. Okay, now this shape is getting deducted from the square and the same shape is getting added to this square at the top. So we can say it is tessellating. Let's come to option number B. Again, we've drawn a square around it. Okay, we are deducting this shape from the left and we are adding the same shape towards the right. Okay, again we can say that this is also going to tessellate. Okay, let's check for C. What is happening here is we are deducting a rectangle from the right, but we are adding a quadrilateral plus another quadrilateral over here. So in this case, it is not going to tessellate. Now what will happen if we were to try and tessellate this? This particular square will fit in only till here and it will continue in this manner. So leaving this particular gap on both the sides, above and bottom. So this is not going to tessellate. Let's check for option number D. What is happening here is okay, we are deducting this shape in this form and we are adding the same shape on the right side. But please note that this angle and the length and this angle and the length is not the same. Okay, this line and this line, the length is also changing and the angle is also changing. So this is also not going to tessellate. So the correct answer here is A is going to tessellate, B is going to tessellate, C is not going to tessellate, and D is not going to tessellate. So in MSQ we have A and B as the correct answer. Let's check for this. Again, we have a tile and the tessellation is very normal without flipping and without rotating it. Let's check for all these examples. Are they going to tessellate or not? Okay, let's start with option number A. First of all, let's draw a square around it. Okay, what are we doing is we are subtracting this L shape from bottom and we are adding this L shape at the top. So for the first one or for the first checkpoint, that is bottom and top, it is going to tessellate. Now let's check what's happening with left and right. We are adding something here and the same shape in the same size we are deducting from the right side. So we know that A is going to tessellate. Okay, A is going to tessellate. Now what is happening with B? First of all, we have this one curve at the top, but we do not have any such curve at the bottom. So when it tries and fixes with each other, it is definitely going to leave some kind of a gap. Also, towards the right we see a curve and towards the left we do not see a similar curve. So by both these means, top and bottom and left and right, it is not going to tessellate. So option number B is not going to tessellate, or the shape in option number B is not going to tessellate. Let's check what is happening in option number C. Okay, we have drawn a shape over here. Let's see what is happening. Towards the left, we have this shape that is getting added and this shape which is getting deducted. So yes, holds true. Now again in this portion, we see a quadrilateral getting deducted and we see a quadrilateral getting added. So this may also be true with respect to tessellation. Now let's move ahead. What is happening with this is, there is a shape like this that is getting subtracted, but we do not have any similar shape which is getting added. For example, we can say that this triangle and this triangle is same, but nothing similar with respect to this is getting repeated. So C is not going to tessellate. Let's check what is happening with the elephant in option D. If we try and make a square around it, this particular square, let's check what is happening. This semicircular or U kind of thing is getting subtracted from here and it is getting added over here. This curve is getting subtracted from this and it is getting added over here. Okay, for top and bottom we are good to go. We can see that it is going to tessellate. Now what is happening with this? You have a small portion which has been deducted from here and the small portion has been added towards the right near the limb of the elephant. Now what is happening here? This particular shape is getting added in this and it is getting subtracted from this, and hence we get elephant like shape over here. Okay? So this portion is going to fit exactly here. This portion is going to fit with this exactly. This portion is going to fit with this exactly. Okay? So we can say that this D option is going to tessellate. So for us, A is going to tessellate, B is not going to tessellate, C is not going to tessellate, and D is going to tessellate. So A and D are the correct answers in this. Okay, I hope with this trick you will be able to solve tessellation very easily. Now please solve for this. Okay, use the same trick. I hope you have noticed that again this is getting repeated without flipping or without rotating. Let's check for option A, B, C and D. What is happening here is, let's try and draw another square. Okay, this curve gets subtracted from the bottom, gets added at the top, correct? This curve is getting added towards the left, getting subtracted from the right. Okay, so this is going to tessellate. Let's check for C. This curve is going to fit exactly into this curve, okay? And the rest of the shape is going to fit exactly into one another, okay? So this is going to tessellate. Let's check for B. Okay. Okay, now let's check for B. Okay. We see that this portion getting deducted is not getting added over here in the similar manner. Again, even if we try and draw a square around this particular curve is getting deducted from here, but it's not getting added anywhere over here. Okay, so we know that it is not going to tessellate. We do not have to check whether it will tessellate once we rotate it, because in the example we see the object or the tile is not rotating nor flipping. So directly we can say that B is not going to tessellate. Let's check for option number D. This curve fits directly into this curve. Okay, and let's try and draw a circle, a square around this, and let's check what is happening. Okay, let's check what is happening. We are deducting a triangle from here and we are adding this triangle here. So for top and bottom, yes, it can be done. Now we are deducting a shape like this from left and we are adding the same shape over here in the right. So this is going to tessellate. So the correct answer for us is A, C and D are going to tessellate. With this, we are done with the tessellation chapter. I hope that you have understood tessellation very well and will be able to do the practice questions really well. Now let us move to the next type, that is tangram. What happens in a tangram is a square is divided into 7 further shapes. You get a big triangle, another big triangle, you get 2 small triangles, you get a parallelogram, you get a square and you get a medium shaped triangle. In tangram, you'll always find the square being divided into these shapes. So you can remember it to solve the tangram questions in your exam quickly. Okay, so let us write it down. A square is getting divided into 2 big triangles, 2 small triangles, 1 medium triangle, one parallelogram, and one square. Okay, you can remember it for the ease of solving questions in exams. And with these smaller shapes, you can make n number of patterns, n number of diagrams. For example, let's check what is happening in this particular square. There is a big triangle, another big triangle, there is a square, there are two smaller triangles, there is a medium triangle, and there is a parallelogram. With the help of all these shapes, another shape has been formed. For example, you can make a duck, you can make a goat, you can make a fish, you can make a horse, you can make n number of shapes with this. Now, what kind of question are asked in our exam? Which of the following compositions is possible by rearranging pieces of tangram puzzle? Sample is given on the left. Okay, rotation of the pieces is allowed, but flipping and scaling is not allowed. What is flipping? Completely flipping it like this is a triangle and you are completely flipping it, or using a mirror image. That is not allowed, and scaling is not allowed. For example, this is the shape or this is the scale of the triangle, and in your option something like this is given. So scaling and flipping is not allowed. Now you have to tell which of this rotation, which of these shapes you can get from rotation of the pieces from this tangram. Now let's check whether we are getting the same shapes from here or not. One big triangle, second big triangle, a medium triangle, two small triangles, a square, and a parallelogram. Okay, so yes, we are good to go. But also note that there are 7 shapes that we are getting from this. So before we look into the various shapes that are there in these diagrams, let us first check that all these diagrams, whether they have 7 shapes or not. This will help you in eliminating the wrong answer. Let's start with option number A. 1, 2, 3, 4, 5, 6, 7. Okay. So far it is okay. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. Again okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is giving us 9 shapes, so we can directly eliminate option number D. Okay. Now let us check whether there is a square or not. That is 6. We have a square here, we have a square here, we also have a square here. Okay. Let's check whether it has 2 small triangles or not. Okay. We have 1 small triangle, 2 small triangle. We have 1 small triangle, 2 small triangle, but we have a third small triangle as well, which is not allowed. So B has also been eliminated from here. Let's check with respect to C what is happening. We have 1 small triangle, 2 small triangle, and 3 small triangles. So again, C gets deducted, and the correct answer for us is A. Now let's be double sure. Let's check with other shapes as well. 7 is there, square is there, 2 smaller triangles are there. Let's check for parallelogram. Yes, we have the parallelogram as well. Let's check for 1 medium triangle. Yes, we have, and 2 bigger triangles or large triangles also we have. So we can be double sure that yes, option number A is the correct answer. Let's move ahead. Okay, a child accidentally drops a square ceramic tile. It breaks into smaller pieces as shown in figure number P. To avoid a scolding, she plans to compose a mural out of broken pieces to give to her mother. Which figure out of the given options could she make? Okay, now again we are coming to the same basic. A square has been divided into 2 big triangles, 1 parallelogram, 1 square, 2 smaller triangles, and 1 medium sized triangle. Exactly the same. Okay, now let's begin with counting the number of shapes. Okay, that is the first step that we will do. 1, 2, 3, 4, 5, 6, 7, 8. So eliminated. It should be what? It should be 7. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Again, D is not the correct option. So now we have to choose between A and B. Let's start with a square. Do we have a square here? Yes. Is it of the same shape and is it of the same size? Yes. Okay, let's check a square here. Is it of the same size? Yes, it has rotated, but rotation is allowed in this particular question. So we are good to go with respect to the square. Let's check with respect to parallelogram. Parallelogram we have over here of the same scale. Parallelogram we have of the same scale. Let's check for smaller triangles. One small triangle, two small triangle and three small triangles. So this is wrong. Okay, so A and D have been eliminated. Let's check with the square. We have a square here, we have a square here, we have a square here. Okay, now let's check for the parallelogram. We have a parallelogram here as well and here as well. Okay, so far good to go. Let's check for two smaller triangles. We have two small triangles. Let's check for two big or large triangles. Yes, let's check for a medium sized triangle. We have it here, but we do not have it over here. Instead of that, we have a parallelogram. So B has also been eliminated and C is the correct option for us. Let us again check whether we've got the answer right or not. Okay, what do we need? A square. We need a parallelogram, we need two small triangles, we need one medium triangle and we need two large triangles. So we are double sure that option number C is correct for us. Okay, let's look at this question. This is a question from CEED 2017, question number 18. It says, image below shows the parts of a tangram. Size of one of the parts has been changed in one or more of the options. Identify those options. Let us look into what the question is saying. Size of one of the parts has been changed in one or more. So there is scaling and the scaling can be in one option or it can be in more than one option. So this is a MSQ type of question to begin with. Okay, how to start identifying the scaling? Let's focus on one shape at a time. For example, let's start with square, then we will see the scaling of parallelogram and then we will see the scaling of the triangles and we will try to figure out where the scaling has happened in which of the object and in which of the shape. Let's begin with the square. Here the size of the square looks similar to that of the original square. Okay, so for this square we have a go ahead. Let's check for option number B. Again a go ahead from square point of view. Let's check option C. Now in this you will notice that the size of square has increased. It is not equal to the size of square that we have in the sample. So this definitely is the odd one out. Let's check for the other as well. Okay, the square size is same as the sample. Let's begin with A now with the option of a parallelogram. Okay, where is the parallelogram? First of all, in the tail. So the size looks same as that of the sample. So we have a go ahead from parallelogram for option number B. Let's try for option number A. Let's try for option number B. Okay. The parallelogram size looks scaled up. It is not equal to the size of the parallelogram given in the sample. So again, option B is an odd one out for us. Let's check for option number D. Parallelogram size looks same as that of the sample. So we have a go ahead for option number D. Let's check for the two smaller triangles also. We have them in the head, the ear part of it. So go ahead for option A, go ahead for option B, go ahead for option C, and that is okay with respect to option D as well. Okay, let's move on to the next one, that is medium sized triangle. That is there somewhere near the limbs. So, okay, the size is the same. Here also size is the same. Here also size is the same, and same holds true for option number D as well. Now, the last thing that we need to look into is the two large triangles that we have. So, 1 and 2. Now this we will find in the body part of the cat. So size same for option A, same for option B, same for option C, and same for option number D. So at the end of solving it one by one, we know that the odd ones out are B and C, in which one or more shapes have been scaled up. So the answer for us is B as well as C. Moving on to the next question. Let's read the question first. Tile X was used to create a seamless pattern when arranged as shown below. So just by looking at the sample, we know that it is a question from tessellation. Okay, let's move ahead. Which tiles, S meaning it's a MSQ type of question. Which tiles from the options will create a seamless pattern without gaps? Okay, now this is slightly different from the kind of questions that we've been solving so far. What we've been doing is, till now we have been placing one shape next to the other shape only. We've not been flipping it and we've not been rotating it. But in this one, if you look closely at the pattern, you will see that this particular tile moves horizontally, it's placed horizontally, and these tiles are placed vertically. So there is a rotation of 90 degree between two tiles. Okay. Now let us try to understand how to solve these type of questions. Till now we've been trying to put that particular shape in a square, and then we've been seeing that the bottom part is exactly the same as the top part and the left part is exactly the same as the right part. Now will that trick work here? No, because this particular part needs to get arranged in this part, since it is going to get rotated 90 degree. Okay, so now our check or our trick changes. Now what we will see is, we will check whether the part that has been added here or has been removed from here, that is the left or the right part, can exactly fit at the top or the bottom part. Okay, so let's check. This triangle completely fits here in this portion of a triangle, hence it is able to tessellate. Let's check for option number B. No, here we have a triangle and here we do not have a triangular shape. So no, this cannot tessellate. Let's check for the other example. This and this, yes, they look alike. Based on this, they can tessellate. Let's check for the right portion and the above portion. As you can see, the line and the shape of it is not same. So B can also not tessellate. Let's check for C. This particular line can overlap exactly with this line. So yes, our shape C can tessellate. And let's check for now option number D. This particular pattern made with the curved line is same exactly like the one at the top, the shape that the curved line is making. So option number D can also tessellate. So for this, the MSQ type, we have C and D that can tessellate. So that is the answer for us.